Good morning and welcome to Inner West Council Library. We present an HSC lecture series in partnership with First Class Tutoring. But before all, I would like to acknowledge the traditional custodian of the land on which we produce this series, the Gadigal and Wangal people of the Eora Nation, and show my respect to their elders past, present and emerging, and to all First Australian watching this series with us. Enjoy and good luck for your exam after a very, very hard year.
The HSC video series focuses on providing students with insights into the HSC examination and how to best prepare for the HSC. The video will be broken down into 3 parts. Part 1 of the series will focus on how to best prepare for the physics trial and HSC examinations. Part 2 will break down the exam and provide you with insights on its structure and techniques to complete the exam effectively. Part 3 will explore last year's HSC and identify the ideas and concepts that are favoured by the examination board. Let's begin by looking at what you need to do to start preparing for the examinations. The first thing you should start doing is preparing summary notes. You will use the syllabus as your guide and the dot points contained within the syllabus to form the basis of your summary notes. When it comes to revising your notes, it may be easier to chunk the syllabus into inquiry questions as opposed to dealing with each dot point individually. For example, Module 7, Inquiry Question 3. The focus is on the quantum model of light. Now, instead of revising every single dot point, you may instead just want to focus on the concept put forth by the syllabus here, which is how has the nature of light changed from the particle model to the wave model to now the quantum model of light. By chunking the syllabus up into easily digestible concepts like this, it will make revising the material much easier. Also, don't forget about the working scientifically skills. These are becoming a major focus for examiners and will feature heavily when we look at the 2019 exam and the questions that they have asked. After you've compiled all of your summary notes, you should look to add to these summary notes in 2 different areas. The first one will be the contributions of key scientists mentioned throughout the syllabus. From the previous physics syllabus, we've seen an increase in the number of scientists mentioned by name. Now, this means that the examiners can ask about any of these scientists, so you should be aware of the scientists, their work, and the implications of their work. The easiest way to do this would be to develop a table where you place the names of all of the scientists who are featured throughout the syllabus into this table. Then, look at the theory or the proposal of that scientist. For example, here we have Louis de Broglie. Now, Louis de Broglie's proposal was matter waves. Next, we'll look at either the experiment or the experimental evidence which supported this theory or proposal. So, de Broglie based his ideas on the symmetry of the universe and was using the results from the photoelectric effect experiments that Einstein had earlier explained, where he had described the fact that waves behaved as particles. So de Broglie took this understanding and applied the inverse of this, that matter also behaved as waves. The experimental evidence, which later supported Louis de Broglie, was the work of Davison and Germer. So it's important to mention that so that if a question is asked about de Broglie and maybe the experimental evidence that supported his theories, you at least know the work that supported the scientist's proposal. The final thing you should look at is the implications of this work on the scientific community. This will be a big feature of your 6 and 7 and 8 mark questions. So you need to know, firstly, what was the idea before it and what impact did this idea have on the community following it. So any particle that has momentum is also considered to be a wave, which means that all particles of matter have a wavelength. And this wavelength can be calculated through the formula identified. So these implications had massive effects on the field of quantum physics. And so these should be compiled for every scientist who are mentioned throughout the syllabus. The next thing you should focus on is the experiments that are mentioned throughout the syllabus. Now, while there was a decrease in the amount of first-hand investigations that you had to perform throughout the syllabus, there is a massive increase on the focus on the skills from these experiments. And these skills are going to be featured heavily in the exam. So if we have a look at the first-hand investigations that you would have had to complete in your Year 12 HSC Physics year, you see there are not many experiments to report on from the Advanced Mechanics module. There's a few more from the electromagnetism module. The nature of light has the most amount of first-hand experiments, and from the universe to the atom has a few experiments to complete. So for each of these experiments, you should develop another summary table. So an example of what your summary table would look like is displayed on the screen now. So you should have your experiment, the aim of the experiment, identify all of your variables, the equipment required, risk assessments, a method, results, and instead of a discussion, focus instead on the sources of error. Okay, so let's have a look at an example of one. The nature of light, we're asked to investigate Malus' law. Now the aim for this experiment is to see the effect of the angle of the analyzer, which is your two polarizing lenses, what the angle between those two lenses does on the intensity of light transmitted between those. So your independent variable is the angle created between the two polarizing filters. Your dependent variable is your intensity. Okay. Notice the detail here is only enough detail for you to understand what has happened in this experiment. If you need a lot more detail, for example, if your risk assessment, you want to identify the risk, the management strategy in order to curtail that risk, you might want to go into all of that detail. Some students, it might just be simple enough that you just identify the risks and you can remember what you did to mitigate those risks. Moving on from that. The same can be said about your method and your results. If you need an incredibly detailed method, you want to remember every single step that you performed, then go ahead and write a summary of that experimental method in its entirety. If you can remember what you did in that experiment, maybe a short paragraph will suffice for this section here. The main focus should be on the results that you obtained and some potential sources of error in your investigation. So here we want to make sure that we discuss our results and what the implications of those results were. So we see here as the angle increased, the intensity decreased, demonstrating an inverse relationship. And it's important to pull out these relationships to discuss later in some potential questions. We should also try and tie this to any formula from the syllabus. So here we see that Malus' law can be used to show the relationship between the intensity and the cosine squared of the angle between the two lenses. And this should also produce a linear relationship. Our sources of error can be something as simple as the ambient light in the room for this investigation, the position of the lenses, or something that the experimenter did, such as their hands got in the way of the light source, which may have caused some error with the readings. Now, what I would suggest you would do is identify all of your potential sources of error, and from here, categorize those as either affecting the accuracy, reliability, or validity of the investigation. On top of this, you should also look to include a suggested improvement. So in an ideal experiment, how would you address these shortcomings? What would be the steps? What would be the potential equipment you could use? Because all of this information can be asked of you throughout the exam. So now that we have a summary of the entire syllabus, we have a summary of the key scientists from the syllabus, and we also have a summary of all of the first-hand investigations, we can start moving into additional practice to prepare for the exam. The first thing I would suggest doing is developing concept maps for the syllabus. Now these are useful for identifying relationships throughout the syllabus. And when we're looking at our larger mark single item questions, our 6, our 7, our 8, potentially 9 mark questions, they're not going to be based on a single area within the syllabus. They are going to ask you to make links within the different areas of the syllabus and potentially across modules within the syllabus. One question might ask you to tie in an understanding of from universe to atom with some advanced mechanics understanding. And some of the top questions will also ask you to pull in your knowledge from the Year 11 syllabus, so Module 1 and Module 2, 3, 4. When we get to this part of the video, we'll see how last year's exam actually tied in information from Module 1 and Module 2 of the Year 11 syllabus. So the first step we should do is start preparing some concept maps. Once we can see that all laid out in front of us, and we'll start to identify the relationships between the whole syllabus, how scientists influenced other scientists, and how the evolution of the scientific understanding developed over time. Following on from this, we should start working with our peers. So form study groups. Now, study groups have numerous benefits. For one, you can compare summary notes with your peers from that study group. So this allows you to see how other people have expressed an understanding of the syllabus, and it might even give you some tips on better language techniques for expressing your ideas. You might find that you like the way that another student has written their summary for a particular dot point and asked to copy that part. In exchange, they might like one part of your summary notes. So it's about sharing and collaborating with your peers. Next, I would suggest taking the initiative to become an expert in a particular field of the syllabus. I mean, ideally, we all want to be experts at every single part of the syllabus, but some parts might be a little bit more difficult. Now, once you become an expert at a particular part of the syllabus, take some time to try and teach that area to your peers. By acting as a teacher, it allows you to identify gaps in your understanding of the syllabus, and it also provides your peers an opportunity to ask you questions that you might not have considered before, questions you might not have the answer to. And this is perfect because this identifies the gaps in your understanding and allows you to go back to that relevant part of the syllabus and top up on your understanding. Whilst you might understand most areas, it could identify some holes which are better identified before you go in and sit your exams. The final thing I would suggest would be engaging in some positive discussions. Now, most of the time when the groups get together, it's a bunch of fear-mongering. This is going to be in the exam, causes a lot of panic, a lot of misinformation is spread. So instead of that, focus on some positive discussions. How can we approach this style of question? How are we best able to convey our understanding for this particular part of the examination? This can also be done online. There's a bunch of online forums. Board of Studies is an example where students jump on, share ideas. They've even been known to share practice examinations as well, examinations from their own schools, and encouraging that collaboration between other peers is very useful to help you prepare for your HSC exam. The final area we'll look at is completing some past papers. Now, past papers are ideal for identifying the holes in your understanding, but also coming to terms with patterns in questions from examiners, and also identifying what the marking criteria are looking for in respect to certain questions. So, with your past papers, make sure that you get them marked. You want to make sure that your teacher is providing you with feedback that you can then use to assist in preparing for future exams or assist in revising those concepts. Not only should you use the teacher's feedback, you should also look at the marking criteria yourself. Now, the marking criteria itself provides you with insights for what the marker is looking for in the response. And the more familiar you get with those marking criteria, the easier it is to recognize trends and patterns in the questions and the style of questioning that markers are using. And you can link those trends together and develop a response that's most suitable for this. So, once you've completed a few practice exams, you want to make sure that you're instead focusing on your weaknesses. Now, you might get your 3-hour-long exam and have a look at it and notice, oh, fantastic, there's some questions on projectile motion. I'm good with mathematics, so they're going to be easier ones. What I would instead encourage you to do is just skip that section. If you're already killing projectile motion calculations, there's no point going back and continually practicing them over and over again. I mean, it is good for the ego, but really you want to focus on your weaknesses, making sure you're getting better at those. Now, I'm not saying stop doing any projectile motion questions if that's your strong area. Keep it on the back burner, but instead focus on your weaknesses, because these are the things that are going to get you those additional marks when it comes time for your examination. Now, yes, there has only been one past paper with the new syllabus, the 2019 HSC. There's also the trial paper you could use from the 2019 HSC. However, because it's a new syllabus, does not mean that we can't use the material from the old syllabus. In fact, they've just recycled a lot of the dot points from the old syllabus to comprise the new syllabus. We see advanced mechanics is really just made up of the first 3 focus areas of the space topic from the old syllabus. Electromagnetism is essentially a cut and paste from the motors and generators syllabus. There's obviously the removal of the contributions of Edison and Westinghouse, but in essence, it's a cut and paste. Module 7, the nature of light, is actually taken from 4 different areas of the old syllabus, and so this is where it can get a bit tricky to find the appropriate questions. My guide would be use those syllabus numbers, the 9.2.4, and have a look at the marking criteria. We'll go into how we can use those marking criteria to best prepare for the HSC as well in a minute. And from universe to atom, we see that that's actually comprised of one section of the ideas to implementation unit and all of the quanta to quarks option module from the old syllabus. Now, there are some parts we're missing. The impact on society and environment are missing. The Manhattan Project is missing from the quanta to quarks. But overall, majority of the content can be carried forward from the old syllabus into the new syllabus. Now, when I get a past HSC exam, the first thing I would suggest doing is going right to the bottom of the marking guidelines. Now, you can get the marking guidelines from the NESA exam packs that are online, and at the bottom of the HSC marking guidelines, you will find a mapping grid. The mapping grid links all of the questions from that exam to the relevant syllabus content. Now we can see here that the first question is related to 9.3.1, and then 3.5 refers to the inquiry question and the specific dot point that it is mentioning. Now, if you go to the previous part of this presentation, we can see that 9.3.1 in the motors and generators syllabus now links up with Module 7, the nature of light. So I would highlight question 1 from the 2015 HSC Physics exam and say that this is a question that I can practice to develop my understanding of the nature of light. Okay, now this can be quite difficult, quite time consuming to go through all of the mapping grids for the past HSCs. So HSC Ninja has already done this for us. It has gone through all of the past HSC papers, broken down all of the exams into their relevant dot points, and under each of the headings you can see that there are a certain number of questions that have been asked in previous HSCs about those particular areas. And simply by reading the dot points, we can make the links between the old syllabus dot points and the new syllabus dot points. So using HSC Ninja is a very effective way to practice individual questions on certain dot points from the syllabus. So, in summation, we should be looking to prepare summary notes based on the dot points from the HSC syllabus, and it's important not to forget about those working scientifically skills. We should have summaries of all of the work of the scientists that are mentioned by name in the syllabus, as well as the first-hand investigations that we've performed. Once you have those 3 things, you should look to create a study group with your peers either at your school, at your local library, or even online. Become an expert, act as a teacher, encourage your peers to ask questions of you in order to identify your weaknesses. Engage in positive discussions, and remember, the best practice is doing the exams that have come before you. by doing the exams that have come before you, you can identify trends and patterns in the way that the examiners ask the questions, but also look at those marking criteria and try to identify trends in what they are looking for from your answers. In part 2 of the video lecture series, we will look to break down the HSC examination and identify some techniques that will be useful in completing the examinations. In the trial and the HSC examinations, they will be comprised of 2 parts. The first part will be worth 20 marks and solely comprised of multiple choice questions. The second section will be comprised of extended response questions totaling 80 marks. Now, an extended response can range from 1 to 9 marks for a single item, or additional marks could be awarded if the item is comprised of multiple parts. So for example, last year's HSC had a 9-mark single item question. There was also an 8-mark multiple part question. So these are the structure of the questions that could be asked of you. Next, we'll look at how to allocate our time when completing the HSC examination. Now, we could simply break this up into 2 sections based on their weightings and allow 20% of our time to go towards multiple choice, which is 36 minutes, and we could use the remaining 144 minutes to complete the extended response section. This would seem logical because these are the weightings that are awarded for each section of the examination. Or we could be a little bit more creative with our time and become more efficient as we deal with one of the major inhibitors of performance, which is stress. Now, every student will experience some stress around a major event such as the HSC examination, and this stress can prevent you from achieving your best, or even worse, negate all of your efforts leading up to the examination. So let's explore how we can maximize your time during the exam and deal with the mental blanks that arise from stress. Now picture this. You enter the examination room, you're filled with nervous energy, anticipating the questions that are about to face you. Maybe there's some excitement, maybe there's some fear. The supervisor calls out, you may commence your reading time. You start flicking through the pages, and there it is, the most disgusting question you've ever seen. You have no idea what it's asking or what to write about. You start panicking. You start thinking back to all of the content that you can remember, all of the content you revised coming into the exam, and questioning everything you did to prepare for the exam. You're quickly losing confidence, and what's worse, you're struggling to address some of the questions that you should find easy, because you can't stop thinking about the horrible question that's about to come. This is the worst position that you could possibly be in, but there are ways of dealing with this. Now, to deal with this, we need to remember that confidence is the key to success, and confidence comes through planning. So use your reading time wisely. Start planning your extended response answers during the reading time. Focus on the positives. Focus on those questions that you can complete straight away. The ones that you have all of your ideas, that everything you have revised is coming back to you for those particular questions. The questions that are going to be incredibly difficult, the ones that you can't remember the material for, leave those ones for the time being, because as we will see, we might be able to get clues from earlier parts of the exam to deal with those questions. So, whilst you are reading, you should look for links between the questions. For example, whilst you read through the multiple choice questions, you should see if any of those questions link up with some of the questions from the extended response section. So now that reading time is over, you can start preparing for the exam. First thing you should do is, once your writing time is complete, you should get out all of the information that is in your head straight away. You should write your ideas for the extended response questions in the margins of the pages. Okay, now for this you can use the TLC method. We'll get more into this TLC method later on. But you can also write any relationships, any formulas, any particular dot points or scientists or experiments you can think of that relate or will help you with answering some of the questions. The best part about this is that once you get into the examination, you might have some mental blanks along the way. But if you get all of the information out before you even commence the exam, then when you get to those questions and you have a slight mental blank, you already have some cues there for what you need to do to answer that question. Now, once you've got all of your ideas down, I would suggest going back and starting with the multiple choice section. Now, the multiple choice section can seem like it's the easiest part of the exam and you might want to leave that till last once you're exhausted. However, I would suggest doing it first because you can find some clues within the questions that they're asking you which may be able to assist you with the extended response section. Now, once you've completed the multiple choice and you've answered every single one of the multiple choice questions, move on to the extended response questions. Now, you can incorporate any additional information that you found from the multiple choice section, plus you can incorporate the notes that you've already made in that first little bit of planning time that you had before you started the examination. Let's see an example from last year's HSC paper to see how clues are present in the multiple choice section. Question number 2 in last year's HSC examination was a question that was looking at the spectral lines produced by 2 different sources. And we can see here in the question that the 2 categories they're looking at is motion relative to the Earth and chemical composition. Now, if we skip forward to question number 22 in the extended response, we see that it is also asking a question based on the stellar spectra. And it is asking us to talk about information regarding other features of stars. Now, the first thing that a student can do is use the TLC method. Now, the TLC method looks to identify what the task verb is. So in this case, we put a box around the word describe. And if a question is asking us to describe, we should know that that is asking us to provide characteristics or features of what's to come after that. The next thing we should do is look for the limiting factors of this question, and we can underline those. Now, the limiting factors here, it refers to the other features of stars, and the preamble before this question identifies chemical composition and surface temperature. So I'm limited by this question by only discussing other features of stars, and if I look back at my dot point, I know that those features encompass translational, rotational velocity, density, chemical composition, and surface temperature of the star. And the content that is going to need to be addressed in this question is the information that I can obtain from the spectra of the stars. So the information I can obtain from the spectra refer to things like broadening of the spectral lines, the placement or position of those spectral lines, and any shifting that might occur as a result of some of the features of those lines. Now, if we compare question number 2 with question number 22, we see that we've already got a clue from the multiple choice question. In the multiple choice question, it mentioned chemical composition and motion relative to Earth. So I already know of one feature that can be provided based on the stellar spectra of a star. Now, the next clue here is in the term features. It obviously wants plural, but based on the multiple choice question alone, and just simply reciting the fact that relative motion between the observer and the star will produce a shift in the spectral lines, I'm already eligible for 2 out of the 3 marks. That's without bringing of any of my additional information into this question. It's simply taken what was given to me in question 2 of the multiple choice. If I have a look at the dot point, I remember that rotational and translational velocity can be mentioned. So then it's just simply up to me which second feature I'm going to include in my answer. We can see here that we are talking about the density of the star as a result of the absorption and narrow spectral lines with less dense stars. So the sample answer has addressed density. It has also addressed the motion of the star. Lower frequencies indicating that the star is moving away from the observer, so we are having a redshift effect take place. If we want to talk about the rotational velocity, we will talk about the broadening of spectral lines due to the red and blue shift occurring as a result of the star spinning relative to the observer. So there's an example of how the stimulus from the multiple choice section can assist me in completing some of the extended response questions. So if we have a look at how we should actually allocate our time, during the HSC exam, I would suggest using the first 5 to 10 minutes to get all of that information that's in your head out onto your page. Start planning your extended response, getting those formulas down, identifying those links, relationships that maybe later on, once you've completed a few questions and you're starting to feel a bit fatigued, you might start to forget about some of those. Once you've done your planning, move into your multiple choice. We can afford to remove some of the time with multiple choice because it definitely won't take up 20% of our time. So by allocating about 25 minutes to complete the multiple choice section, it gives us about 135 minutes to complete the extended response. Even though that's a reduction in time from the 144 previously mentioned, because we've done our planning, it should become easier to answer our extended response questions as opposed to trying to think up all of our answers as we approach each question. Finally, if you're finished early, always go back and revise your exam. There may be a piece of information that you did not think of straight away that you could then put back into your answers. You should also read back through your answers. Check that they are logical, check that they are coherent, because a marker might be able to see the point that you are trying to make. However, the way in which you have conveyed your understanding does not warrant the full marks. A little quote: if you don't plan, how do you plan to succeed? So this should be the idea that you have in your head when you're approaching the examinations. I should be looking to plan how I'm going to attack this exam, what information I'm going to include in each of the extended response questions. Otherwise, it may get to a point where I'm feeling flustered and I'm not able to achieve my best. So in summation, use your reading time effectively. Make sure that you try and create those links between the multiple choice section and the extended response section. Plan out your exam. Once writing time commences, go through, get all of that information out onto the page that you've been storing up during the reading time. Look for the clues in the questions and the stimulus provided to you. The examiners are providing ample stimulus and asking you to interpret that stimulus. Now, it may be a graph, it may be an image, it may be a table of results. But there are lots and lots of clues that will help us to answer the questions through those stimulus. Remember, attempt every single question. 1 mark can be the difference between your Band 6 and your Band 5 result. So make sure you get something down onto the page, because something as simple as identifying a relevant piece of information is enough to warrant a single mark, which might get you over the edge. And always, always go back and review your work. You want to make sure that your understanding is coming across clear, logical, and coherent. In part 3 of the video lecture series, we will explore the content that was contained in the 2019 HSC examination and try and identify some trends in the examination questions that we can use to help us prepare for this year's HSC examination. Firstly, if we consider the verbs that were asked in the extended response questions, we see that explain and describe made up the majority of the marks for the extended response section. In fact, the explain question was responsible for a single item 7-mark question, and the describe verb was responsible for a 9-mark single item question. Now we see that those higher order verbs such as justify and assess are featured rarely in last year's HSC examination. And what this shows is that the examiners are instead looking for us to identify the relationships between different phenomena in the physics syllabus and draw out those relationships using cause and effect language, or provide features of an investigation or of data presented to the student themselves. We see that the HSC examination was loaded with stimulus. This is in the form of diagrams, graphs, and tables of results. Now, this should give us an indication of what they're going to be asking in this year's HSC examination. They have hinted that they want students to be able to respond to new and unfamiliar situations by drawing in their knowledge of the HSC syllabus. So let's have a look at an example of one of the questions from last year's exam. Here we see a question which shows there's an electromagnetic wave and asks us to relate the model of the electromagnetic wave to the predictions made by Maxwell. Now the dot point here is obviously referring to Maxwell's predictions of the electromagnetic waves and some of the features that he predicted by unifying those electric and magnetic concepts. So, what can we see just from the stimulus alone? Now it's important that we draw everything we can from the stimulus. If the marker has gone to the effort of including some kind of visual stimulus, they obviously want us to use it when addressing the question. If we don't do this, we will not enter into those top tiers of the marking criteria. So, what can we see here? We can see that there is an oscillating charge on the left-hand side. It's a positive charge, but for now it doesn't matter too much. We just know that it is an oscillating charge. We can also see that the changes in the electric field that are occurring correspond with the changes in the magnetic field. So when the electric field is reaching its maximum displacement, the magnetic field is too reaching its maximum displacement. We see that the electric field and the magnetic field are acting perpendicular to each other, and that the propagation direction is perpendicular to both of these as well. Finally, on the right-hand side, we can see that the wave is traveling with a velocity denoted by the letter V. So, how does this match up with the syllabus? Well, Maxwell's predictions were that an oscillating electric charge would produce an electromagnetic wave. He also stated that a change in an electric field would induce a change in the magnetic field surrounding it, and vice versa, and this would be self-propagating and continue. The final thing he noted was that electromagnetic waves would exist as part of a spectrum made up of different wavelengths, and that all of the waves that comprise this spectrum would travel at the same speed, the speed of light. So, how can we address this question? Well, let's have a look at the marking criteria and the identifying features that we have pulled out from the stimulus. So, for 4 marks, we need to relate the model to predictions, plural, made by Maxwell. So that's a nice clue straight from the question itself. It says, relate this model to predictions made by Maxwell. Okay, so on the left-hand side, we see we have multiple features that we can talk about with relation to Maxwell's prediction of electromagnetic waves. We see by going down into the 3 and 2 and single mark categories, we just decrease the detail of our answer. So to drop down to a 3, we only relate one prediction made by Maxwell. Okay, and any lower than that, we're just looking at single predictions or single features of this model from the stimulus. So our sample answer shows that the model has an alternating electric and magnetic field acting perpendicular to each other. Now this is consistent with Maxwell's prediction that we identified earlier, where a changing electric field produces a changing magnetic field, vice versa. It also denotes that the wave is propagating with a velocity v, and we've tied that to Maxwell's prediction of the existence of waves in a spectrum all traveling with the same speed. Now you could also include the fact that the oscillating charge would result in an electromagnetic wave emanating from it, which is consistent with his prediction of the same nature. So we can see there are multiple features that we can talk about just based on that stimulus piece alone and relate those to the relevant syllabus outcomes. So what else can we get from last year's HSC paper that might assist us in preparing for this year's HSC and trial examinations? Well, there was a heavy emphasis on the working scientifically skills. We can see that there are numerous questions that asked us about the working scientifically outcomes. Let's have a look at one of the examples now and see how they've tied in those working scientifically skills and the syllabus dot points. So, question 26 is looking at a talk experiment, and it's also provided us a sample graph of their results, a student's results. Now, if we have a look at the first question here, so we can see that we can already draw a lot of information before we even get to the first question. So straight away, I can see that this is going to be a question about torque. And the first thing I think about it with torque is the formula for torque. Now, I can also have a look at the image itself and see that the force is being applied at an angle with respect to the radius and the wrench there. And the graph itself is showing that the gradient is constant. And there's a linear relationship between the torque and the angle of force application. Now, these are things that I can identify or extrapolate before I even have a look at what the question is about. So let's have a look at the question. The first question asks us to justify the validity of the student's model using the information from the graph. So there is some data interpretation that is already being asked of me, one of the working scientifically outcomes, and I'm going to need to report on this by justifying the validity of the student's model. Now, this model is that torque is equal to a constant value multiplied by theta, where that constant value is 1.7 Newton meters per degree. So let's have a look at the graph. We can see that it is increasing in a linear fashion, and this linear fashion produces a constant gradient. So we can say that yes, this model that the student has put forth, that torque is equal to the constant value multiplied by the theta, is demonstrating a gradient that is constant. This is also demonstrating that linear relationship where torque on theta will give us a constant value. So the model put forth by the student is applicable for the range of the data that he has presented in that graph. Okay, so in order to get the full marks for this question, we'll see that you have multiple reasons provided for the validity of the model. So we can agree that this model that the student has put forth, the relationship identified, is valid based on what has been presented to us in the graph. We go on to part 2, and section 2 asks what happens to the accuracy of this model's prediction as the angle increases beyond 25 degrees. Justify our answer with reference to a different model. Now, when they use the word model here, we can also think of a different relationship or a formula that might apply to this situation. So, earlier, we identified that torque was given by R multiplied by force sine theta. And from the image, we can see that the applied force and the radius are constant values in this investigation. So if we use this, we can see that t is going to be equal to sine theta, which, using our understanding of mathematics, will result in this sine wave being produced. Now, this sine wave is consistent with the student's results for what has been displayed in the graph. However, once the angle increases greater than the small angles provided by the student, the model becomes less and less accurate at predicting what is going to happen to that value for torque. In fact, we see once the angle reaches 90 degrees, we see the maximum torque being produced. However, any value that is greater than that 90 all the way up to 180, we in fact see the opposite, where there will be a decreasing amount of torque produced as the angle increases. So this shows that torque does not follow the simple linear relationship demonstrated in the student's model, where torque was equal to k theta, but instead it will take the form of a sine wave, where torque is equal to sine theta. And I can incorporate the formula from the syllabus to assist in my explanation of this answer here. So, what does that mean for us? Well, it means that there is a change in what the markers are looking for in the HSC examination for physics. There's a transition from the rote learning of dot points to now a heavy focus on the application of your understanding of those dot points. We can see that through the increased use of the HSC verbs explain and describe. We also see that there is an increased focus on the working scientifically skills, in particular data interpretation and communication. We see there is a lot more graphical and tabulated information that the marker is looking for us to use in order to convey our understanding. Okay, and the final point there, they are looking for an understanding of the concepts as opposed to simply reciting dot points or just regurgitating all of the information from the textbook. Now, I know there's some of you out there saying, I picked physics because I'm good at math, and I was told there was going to be an increased focus on mathematics with the more equations added to the syllabus. So where are all of the calculations? Well, there were calculations. They didn't lie. There is more focus on the mathematics, but they just want more from you than simple regurgitation of formula or plug and chug. So, projectile motion is pretty consistently featured throughout every HSC physics examination for the last decade or more. Now, a projectile motion question was included in last year's HSC examination. However, it wasn't a simple plug and chug like we've seen in the past. It wanted us to draw in information from previous modules to assist with answering a question from Module 5. So, Part A asks us to calculate the difference in height between P and Q, and in order to do so, we needed to have an understanding of the law of conservation of energy, which was all the way back in Year 11, Module 2, Dynamics. So it's really challenging us to draw on our prior learning, and even though it isn't explicitly assessing that Module 2 outcome, you do require an understanding of the earlier work in the Year 11 syllabus. And for Part B, it is asking us to calculate the height, and in order to do so, we need to draw on our understanding of vectors all the way back from Module 1 in the kinematics unit. So, yes, there was some mathematical applications in the HSC examination, and we should have seen this coming. If we have a look at the 2017 HSC, there was a projectile motion question there. However, this projectile motion question also required us to use a conservation of energy to solve the calculation in the first place. Last year, 2018 HSC examination also had a projectile motion question, but in this one, the focus was instead on skills with reference to the calculations that could be used to explain what was going on in the stimulus piece. So this trend has been happening for 2 years now in the lead up to last year's HSC examination, where they're making the transition from simple plug and chug straight mathematics to now using the applications of the syllabus to explain what is happening for a given situation. Okay, again, they didn't lie to you, they just want more from you than simply applying formula. Let's have a look at this question now, a 7-mark question from this year's HSC. And we can see here that the key verb that is being used is explain. We are explaining why the kinetic energy of the alpha particle is significantly greater than that of the polonium atom. But there is also another clue in there. We are being asked to calculate the kinetic energy. So there is going to be some reference to a formula in this question here. But again, the main focus is on explaining why it is significantly greater. And this question, a single item question, has a weighting of 7 marks. So it's quite a big question. Let's have a look here at what we need to do to address this question. Firstly, we need to draw in our knowledge of mass defect, energy mass equivalence, conservation of energy, and conservation of momentum. 2 concepts that were put forth in the HSC syllabus, but 2 concepts that were addressed in the preliminary HSC syllabus. Okay, so we have our knowledge aspect to this question that is going to help us address the explanation, but we also need some mathematics to that. So we also need to use the mathematics to calculate mass defect, use E equals mc squared to get a value for the energy. We also need to consider the conservation of energy, and on top of that, we need to convert our units as well, which has some semblance of some mathematics work. So let's have a look at what happens if we just do one or the other. Now, band 3 or 4 students would fall into this category. They are able to either just solely do the calculation and not have a very good explanation of why this happens, or vice versa. They know exactly why this happens, but they don't have the mathematics ability to be able to support this. We see a band 5 to 6 student is able to do both of those with varying degrees. So let's have a look at what we need to include. Firstly, the sample answer uses the clue provided by the question. Now the question says that the radon atom is initially at rest. So this gives us an understanding of the particle's motion before the event took place. The sample answer also incorporates knowledge from different modules. It makes reference to some understanding from Module 2 dynamics. It is talking about the fact that momentum is different for the two particles and shows that relationship through P is equal to mv. It also makes the link between momentum and kinetic energy. And by doing so, they also use cause and effect language, which is what an explained question expects us to do. The example there, it therefore has, and consequently. These are examples of the cause and effect language that the markers are looking for in order to put you into those higher band categories. So not only do we see the mathematics, the calculations there for mass defect, the conversions, and the calculation of kinetic energy, there is also reference to the question, which is the effect on the kinetic energy through our understanding of the Module 2 dynamics unit and how this all applies to this question. Now, it's not all bad. There's still some fun stuff out there. For example, 2 of the questions were derivation-based questions in last year's HSC examination. There is also some simple plug and chug questions which you can use for easy marks. These are just simple basic calculations that don't warrant much effort, just simply identifying the correct formula and plugging in the details to produce an answer. So in summary, be sure to use the stimulus that's provided by the examiners. Most questions will ask you to make reference to it in order to get into the top tiers of the marking criteria. You should also look for clues in the questions, things like the use of a plural. That is as simple a way to enter into the top tier of the marking criteria by providing multiple examples as opposed to a single example. There might also be clues by things like mention of conservation laws or even scientists that you can use to help guide you when compiling your response. And remember, you should also draw on your knowledge from the preliminary physics course to help you to address questions from the current examination. This will show a depth of understanding and ability to be able to link concepts within the syllabus with each other. Where to from here? Well, there are many resources out there that will help you on your journey to prepare for the HSC. A few examples of some books include Strive Physics. Now, this book is fantastic. It has gone through all of the past HSCs from 1982 all the way through to 2018 and broke each exam and each question into the relevant module. Now, this is crucial for preparing for each particular module for the HSC examination, but it also provides you access to some examination questions that are not available online. There are also other resources out there which are helpful, such as the Checkpoint series, the Dot Point series, and Excel Physics. Practicing exams is going to be crucial to be in the best possible state to complete the HSC examination. And the way you can do this is accessing the NESA website online and completing the past HSC examinations, or maybe speaking to a teacher and seeing if you can access some of the Catholic trial papers or the independent trial papers. If you're really on top of practicing past examinations, then have a look at some of the VCE exams from Victoria. Their physics syllabus encompasses most of our physics syllabus and will provide you with an additional resource to prepare for our HSC examination. Finally, To assist in your understanding of the HSC syllabus, there are numerous YouTube channels out there that can provide you with additional information regarding the different physics phenomena. High School Physics Explained is the most relevant example for us, as this teacher uses the New South Wales current HSC syllabus and breaks it down to explain all of the tricky concepts to help develop your understanding. In addition to this, the AP Physics course in America and the A-level physics course from the UK can also provide you with an insight into the same physical phenomena that we address in our New South Wales syllabus. Thank you for watching this video lecture series on how to best prepare for the HSC Physics examination. I wish you the best of luck in your preparations for this year's HSC examination.